Oh, thank God, right. Let's we go over that since I now start record, right? So angles of elevation and depression. These angles are always taken from eye level of the person or object. Angle of elevation is looking up, angle of depression is looking down. So you see how this guy here looking at the clouds right here? That is considered angle of elevation. As opposed to this guy who looking at the fish is the angle of depression, but it's taken at that point of eye level. Usually they say like at the horizontal and all those things, but it's so much easier to say, oh well, if I look in, this is my usual eye level. How much do I go down to make that angle? Likewise, this is my eye level here. How much do I go up to make that angle of elevation? I usually use Pythagoras. Why does it usually use Pythagoras? It's because um you'll most likely always get like a right angle triangle. So let me see if I can pull up one here quickly first. If anybody knows one like they know for sure is in our past, we better just put it in chat now instead of me having to search through here. Ah, look on right here. Let's look at this one now. I want you to try it. And don't worry if you don't know how it's done, just wait for me to do it. I'm giving you all 5 minutes first. All right, so me and C no answer from me, but so it looks like you're getting a little trouble out. So let me give you all a little etiquette on how to answer questions, right? So whenever you're given a diagram like this, for me, I just pull out everything I could first. So I say, okay, look at the thing before I even start. This right here is a triangle, right angle triangle. So if this is 90 and this is 40, then this here is 50 degrees. Okay, good. I have that. Right, next thing. If this is 40, then this is 140 degrees. So let's see, they want the angle of elevation of T from P. So I'm gonna get this question here. I say, okay, I'm kind of strange, boy. What do you mean of T from P? So again, I look to see if I could pull out anything else. So I then look at the number of marks it with. It can't be that easy. Of P from T. Look, I draw my eye level at P, and I draw my thing at T. Okay, so my angle elevation is 40 degrees. Very, very simple. Okay, let me go through that again. I draw my eye level at P. Say, okay, cool. And I'm looking up to T. So remember, I just drew the other way. So this is my eye level and then this way. Likewise, this is my eye level and this way. Okay, length FP. So look at this triangle here. Okay, it's 90 degrees. So FP, what can I use? Sine 40. No, that'll work because that's opposite of hypotenuse. Cos 40, no. So it has to be tan 40 is opposite over adjacent. So tan 40 is 80 over FP. FP tan 40 is 80. So FP 80 over tan 40, which is 95.35 meters. 95.35 meters. So now they want the angle of elevation of T from Q. So remember what we was talking about yesterday too, right? Look, I said that from means the angle is at that point. So if you're a little confused, all right? So of T from Q. So I draw my little horizontal here, and this is, so they want this angle here. So they want this angle here. So, and I will tell you all, in the exam, get a little creative. So, okay, this right angle, FQ is 95 plus 118. So we know this is 213.35. We know the height is 80. And we want this angle here, theta, right? So tan theta is opposite over adjacent. Since I say it, tan theta is 80 over 213.35. So theta is tan inverse 80 to 1, which is 20.6 degrees. And that's how you approach a question like that. right? And so when we have that, I want you all to also note something here. These marks are kind of like a guide for how much work you should be doing. So I see 1 mark, I don't want to overcomplicate it. Most likely it's just this 40 here. Likewise, 2 marks, okay, I had to do a little working. And 3 marks, okay, well, I had to do some real working, right? That being said, I also wanted to mention something. You all may have seen it in in your papers when corrected, but it hasn't been explained properly. You all would see something saying ECF, right? That is called error carry forward. So what would happen? Let's just say in the event you get this wrong, right? Let me say I get 100. And so you work with this as 218 instead of the actual value. And let me say do all this right, you will still get the correct answer here and they'll put ECF. Why is that? So you can't get punished twice for making the mistake, right? So what they'll do, they'll give you the mark correctly because you used the thing that you got wrong, but you'll still get the mark for it. All right? So yeah, I want to make note of that. All right, so that's angular elevation and pressure, right? Two, transformations. All right, guys, this is really a reality check here when it comes to um transformations, right? Now is not the time to play hero. There are some basic things in transformations. If you get, you get. You ain't get. Well, that's unfortunate, right? We have three main ones, right? We have rotation. We have, actually, we have a good few. Reflection. We have translation. We have for enlargement. Right? And what does each one represent? Rotation is basically spinning. Now, there's proper words for it, but I just put it in words that you'll understand. Mirroring, sliding, bigger, more, smaller. So let's say I have, this is my original image E, right? This is B. I'll just imagine there's the same shape, right? Just bear with me, right? Then we have C, and then we have, yeah, bigger or smaller. Then we have D, all right? So let's say A is the object, B is a reflection in the y-axis, C is a rotation, D is an enlargement, right? So those are the four main ones you could get. Rotation, reflection, translation, enlargement. So to deal with a rotation, the center of rotation is usually the origin. It's the origin like 90% of the time. But to find center of rotation without, or that is not the origin connect the point of object and image and find perpendicular bisector and where they meet is the origin. Now, honestly, guys, I can't really do this too well without the graph. So I would recommend if you want to know how to find the center of rotation, go and look on a YouTube video and see how to do it, right? I tried to do it using Desmos something, but I can't really do it the way that those do it, right? But honestly, I don't think it would be headache. If they ask you a center of rotation, chances are like 90% of the time it is a along the origin. It's along 0, 0, right? Two, reflection is the mirror image along a line. To find the line, we find the line, we find the midpoint of the line connecting the image and object. So for example, right, what I mean like that. So like you say I had this triangle here, and then I have this triangle here, then this line here. This is the mirror line. That's what I mean. Three, I didn't even do a translation. Yes, shit. All right. Oop, sorry, can I use that language? Um, that E. E is a translation. My bad. Um, three, enlargement is the making of object bigger or smaller of a scale factor, right? So the scale factor is how much times bigger or smaller the object is. Sorry, the image is to the object. Right? The center of enlargement is the intersection of the, yeah, it would be. So a good point, Neri asking if is it still called an enlargement even though the object is being shrunken? Yes. It's very weird wording, I know, but that's true. Yeah, it's the intersection of the lines connecting the object point and the image point. Also, guys, well, those who doing art maths here, just do I raise a hand if you all would want me to do one like this for art maths as well, right? Um, you need to see it, just like let me know if you all would do it. All right, cool. I'll do it and and so let me say I have something like this here, right? And then I have something like this here, right? Um, when I draw the lines like that, and like, I don't want to actually look out. I mean, you'll get the idea, right? I'm just trying to, this will be like the center of enlargement. Obviously, it's not going to be to scale, but you get the idea, right? Also, note, if the center of enlargement is between the object and image, it is negative, right? So let me just say I had like some object like this here, and then some object like this here, and this was the center of enlargement, then this would be like negative. However, if the center enlargement was out here, so this would be negative, and this would be positive. The scale factor, like if k equals 2, it is twice as big, and if k equals a half, it is half as big. And then the other one we have to do is translation. Right? This is the movement of the object. This is the movement of the object without changing shape. I feel like I missed some for the center of rotation. Oh, I should also put, well, I'll put it after, right? Without changing shape or orientation. It moves XY, where X is left to right, and Y is up, down. If X is negative, that is moves left, positive moves right, and then Y, negative, moves down, positive moves up, right? So let's say I have 3 minus 1 moves 3 units right, and 1 unit left. Left? Nope. Top. Right. That's all you need to know with your transformation. But honestly, there's the transformation matrix as well. But like, fellas, don't play hero now. Like, you either get it or you don't get it. That's like a mark or two. I personally would sacrifice. Right? If you struggle with that, I would sacrifice that and just move on to the next one. I gave 0.5, I think I gave you all those matrices to learn off. Learn them off. If you can't remember it, oh well. All right. Now is not the time. Let me try and get. Don't focus on the 5 marks you're losing, focus on the 95 marks you could get, right? The next one was circle theorems. Yeah, boy. All right. This is the one that always comes and always like circle theorem. Just want to copy and paste what I had here for it, right? Should I give a little test on this? Yeah, all right. Let me put on ready. Had some good notes on it, you know. Whatever, yes. Um, because I not drawing no circles over, right? Circle theorems rules. Here it is. It's the same one I gave you. Now, isn't this awkward? When is IT? IT is Tuesday too, right?
Nah, Tuesday.
Thursday? All right. Probably. Okay. Am I really going to open Facebook here, right? Very good. So let me open. So the angles at the center of a circle is twice the angle at the circumference. This one everybody should remember, right? That's the angle made here is 2 times the angle here, right? That one everyone should know. An angle formed by two radii is 90 degrees, right? That one is another one that should know. Not two radii, sorry. The angle formed on a diameter is 90 degrees. Why is that? Because anytime you have to draw it, it'll be two perpendicular lines. Right. The angle from the same arc in the same segment are equal. What does that mean? It basically means that if I was to draw a line here and make this angle and make this angle, you'll see it coming from the same line. We do that again. How that work, right? If I was to draw a line like this, the angle formed on this line is this thing here. So that'll be this angle here. But I could also form the same angle using that there. So they have to be equal. Why? Because of this line here. That's what they mean by the segmented. Once it could form there. Likewise on this side, right? If I form an angle using that, that's a triangle. But let me say I start here and end here, and I make the angle here. And these two also must be equal. That's what I mean by the same segment. I hear the word segment, but yeah. Let me repeat that again. So you see how they both have the same point of starting and point of ending? That's what I mean by in the same segment. All right. Opposite angles in a cyclic quadrilateral add up to 180. What is a cyclic quad? Cyclic quad is a quad that touches all, sorry, what would I say? Where all four corners touch the circle. A lot of people make mistakes with this, right? So let's just say I had a quadrilateral like this, right? And it's only touching here, here, and here. It does not follow the rules of a cyclic quadrilateral. So that means that this and this won't add up. This and this will add up to 180, and this and this will add up to 180 because all four touch in here. So opposite must add up to 180. But if I have one like this, and this and this will not add up to 180. Why is that? Because this point here is not touching the end of the circle. You have to be careful there. This one you don't care about. Let's just X on that one time. The angle between a radius and a tangent must be 90 degrees. Why is that? Those who do hard maths would know a tangent is perpendicular. Those who don't do hard maths, just know if it could only touch at one point, it had to be 90 degrees. Two tangents drawn from the point of the circle are equal. Anytime you see the shape, know that this line here equals this line here. And if these two are 90 degrees, then this and this must add up to 180. This is the one, this last one here is the one everybody does get confused with, right? The angle between a tangent and a chord is equal to the angle at the circumference in the alternate segments. I tell you all from seeing all your papers, all it is always put, if all you don't know the reason, angle in alternate segments, angle in alternate segments, angle in alternate segments, right? Forget that. This is what it means. And then all you say, well, this angle inside, this angle outside, this angle inside, this angle outside, right? What it means is that this line here, making this segment here, and also making this segment here, these two will be equal. Let me repeat that, right? So this angle is formed using this line here. So if this line have an angle forming here, but this line also have an angle forming here, since it's using this same line, that's where the segment comes into play. This segment is alternate to this segment. But what it really means is that, you see this line here? Once it makes an angle here, and it makes an angle here, they should be equal to each other. Likewise, the angle made from this line here and this line here should be equal to each other. That's how it is. Okay? All right. So let's do a couple of these. I actually want to do two of these circle questions, right? And then we'll do vectors and I will upload it and send it. Let me send the link again for all those who did not get it. Okay, so yeah, it's up and loading. Let's show on our channel. I have a few other stuff here. When you go on the channel, you might see a couple other videos. Go ahead and watch them. Bye. But yeah, I'll do one like when is somebody tell me when is AdMats?
Next week, Monday.
Next week Monday, right? So I'll try to do one. I have quarterfinals Saturday. So I'll try to do it Tuesday, Friday, Sunday, something like that. No, I can't do IT, but I will send you all something for IT though. Um, IT, honestly, guys, my best advice for you all in studying that is putting in some use your um use your what do you call it? The AI bots on them, Gemini especially. Gemini does do real good for studying IT. Um, yeah, that's correct. All right. Okay, let's look at this one. I'm giving you all a little time to try it, and then I will do it, right? So take your time with it, put the answers in the chat, but send it as a private message now, so everybody could try it at least. And I will show you. If you get in trouble, I'll show you how to approach a question like this. I'm playing a cricket tournament, so we now make quarters, so hoping for the best there. Thanks, Lucas. Appreciate that. Try a little hard this time though. Also, the so once you have the link to that channel, the videos will show up on that channel one time. All right. So do no business too much about waiting for the link. It'll most likely appear right away.
Wait, say what you said?
The so I send the link to the video. You don't have to wait for the link for this video as well. It'll just be on that channel one time. So, how I will approach questions like this, right? I will approach questions like this was by saying, even if they didn't ask me for it, I'll put it in the I'll put it in whatever angles I know for sure gonna be there. All right, so I say, okay, looking at this thing, this is our diameter here. This had to be 90 degrees. Cool. Anything else I could add? All right, well, if this is 90 degrees here, then this would be 70 degrees. All right, cool. Anything else? Anything else? All right, nothing that coming to mind so far that looks obvious. So let's go. MRQ. MRQ. 70 degrees. Right? Angle in a triangle. So PMN. PMR, sorry. PMR. All right. So looking here. All right. So that is this angle here. All right, cool. So I want this angle inside here. But I know that it is formed using the same line. So let me show you how I got the alternate segments there. I trace to see what they want. They want the PMR. So this is 20, sorry, PMR, that's this here, right? So I look to see if anything else is formed using that line. Oh, look, one is formed here. So if this is 20 degrees, then this will also be 20 degrees. That you see how I applied the um you see how I applied the angles in alternate segments? Again, one more. I always draw this here. I'll show you this one, right? This here, and then I look to see, okay, this is formed on the same line. So this is 20 degrees, angles in alternate segments. Don't do like me. You'll have to write all the full words when you're doing it, right? How I got the 70 degrees. So in a triangle, all of this adds up to 180. I know this is 90 degrees because this is a diameter, which will make this 90 and this 20. So that's 110. So 110 plus how much gives me 180? That is the 70 degrees. So we know this is 20 degrees. Now we want PMN. So we want PMN. So we're trying to get this little piece of angle here. This little piece of angle here, because PMN is this whole thing here. Now, a lot of you would have made a mistake here because you all would think it passed through O. It didn't pass through O. All right, so you're trying to get this little piece here. All right, we're trying to get this little piece here. Is there anything making there? No, so copy that. All right. A bit of a problem here. is the triangle isosceles? Is this angle here isosceles? And let's look back at our rules. Anything like that? Two tangents drawn from the point of a circle are equal. Very good observation. So this here is considered a tangent, and this here is considered a tangent. So therefore, this is equal to this. Very good. Waiting for somebody to notice that. Excellent. So if this is equal to this, then PMN is equal to 180 minus 54 over 2, which is 180 minus 54. That's 126 over 263 degrees. Right? This is 63 degrees. This is angles in an isosceles triangle. Very good. Right? So you always look to see what you could apply. Yeah? Very good. Let's do one more and then we'll do vectors and call that a night, right? Tomorrow I'll go through some. I'll see what else we could go through, and then yeah, maybe some statistics of you. What the statistical diagrams they could bring. Yeah, so tomorrow we'll go through all the statistical diagrams they could bring. What I mean by statistical diagrams, like the cumulative frequency curve, all those things. Histogram, bar chart, bar graph. Yeah. And then how to approach this question. How to approach a paper. We'll do that tomorrow. All right, let's do this one. Yeah, that's fine. Tomorrow I'll try to go not too late, but I'll go a little late, like probably. Yeah, I'll see what I could do tomorrow. Ironically, Zabia was doing I'll show you quickly. I was doing um linear programming with today with applied maths. So those who looking to do applied maths in Form 6, yeah, that's also part of applied. Yeah, Adrian, that's what I was doing today actually, because they have applied Unit 2 tomorrow, pure Unit 2 Wednesday, and pure Unit 1 on Friday. Maths is Tuesday. Yeah. All right. So, as I told you, how would I approach these questions? I would immediately start to put in everything I know. So this here is a radius, so that means there's 90. There 90. If this is 48, then this will be 132. Why? Because these here must add up to 360. If this is 132, then this will be half of that, which is, as what, 66 years? Yeah. Right? So I immediately wrote in everything that I know I need to do, right? So OJH, this is 90 degrees, as this is an angle of a radius and tangent. JOG, this is 132 degrees, angles in a quadrilateral. GKG, which is 66 degrees, and this is angle in center is twice the circumference. And then GLG as this thing here. So watch here. This here is my cyclic quadrilateral. And to show you all, this is the example I was showing you all. There's a cyclic quad because all of these touch the circle, whereas this will not be considered a cyclic quadrilateral because this point here does not touch the circle. So JLG would be same 132 degrees as this is angles in a cyclic quad. All right. So guys, honestly, my opinion with these questions, if you're not getting it, guess though. Don't leave it blank. Don't leave it blank. Because you get a mark for the answer and a mark for the reasoning, right? So imagine you get all the answers wrong, but you put the right thing. You'll get 4 marks out of 8. Sorry, yeah, that's 114. What nonsense I put it. Right? Um, yeah, imagine you get all the things, yeah, no problems. So this here is a cyclic quadrilateral. So that means this angle here and this angle here must add up to 180. So it would be 180 minus 66, which is 114 degrees. Right, that's the last one. So as I say, just put an answer. And this will go for all the maths questions, yeah? Even if you don't know, just put X though. Just put X. Some way, somehow. Just put X. Right. Last thing I did. Right. Vectors. Right. So a vector could be written as xy or xi plus yg. Right. OE is the direction of O to E, where E is the origin. Change in direction means you change the sign. So like if OE is 4, 5, then AO is minus 4. Let's make this minus 5. It's 4 minus 4, 5. You change the sign, right? The magnitude of OA is square root of x squared plus y squared. AB is equal to AO plus OB, right? Make sure that you know that the middle letters must be the same, right? Or it could be like AC plus CB. You get the idea? It's like going from Fatima to Movie Tongue, right? You could go from, okay, Fatima to Westmall, right? You could go from Fatima to Movie Tongue and then Movie Tongue to Westmall. Or you could go from Fatima to Long Circular Mall and then Long Circular Mall to Westmall. Just make sure that the middle point is the same, right? Cool. Dot product. So if I have OA is like x1, y1, OB is x2, y2, and OA dot OB is x1, x2 plus y1, y2. Two vectors are parallel or collinear if one is a multiple of the other and two vectors are perpendicular if their dot product is 0. Cool. So a vector discussion. All right, let's try this one. Okay. So OR, they actually give it in form XY, so you know 6, 2. OS minus 4, 3. All right. SR is SO plus OR, which is 4 minus 3 plus 6, 2, which is 10 minus 1. Magnitude of OS plus 3 squared is root 25.
It's not minus 4, minus 4, 3.
No, because it's SO. So SO is equal to minus OS. Yeah? Because we're going in the opposite direction, we change the sign. Yeah?
That's right.
Cool. So they told us now that OT is 2, 5. So that is somewhere here. And I want to prove that it is a parallelogram. So if it is a parallelogram, was to draw the diagram like that, then two lines are parallel if one is a multiple of the other. So if it's a parallelogram, then ST should be parallel, should be a multiple of OR, because you can see here, these two lines should be parallel, or we could do OS should be a multiple of RT. So let's find ST. I'll do it both ways. You only need to do it one way in exams, but I just do it both. ST is SO plus OT, which is 4 minus 3 plus 2, 5, which is 6, 2. And notice OR is equal to ST. Therefore, they are parallel because one is a multiple of the other. One is 1 times the other. Or if we did this a bit, or if we did RT is RO plus OT, which is minus 6 minus 2 plus 2, 5, which is minus 4 minus 4, 3. So RT is equal to OS, therefore parallel. So you see one is a multiple of the other. So let me explain that again. For something to be a parallelogram, then the sides have to be parallel. Kind of self-explanatory there. And for tell if two things are parallel, then one had to be multiple of the other. So you see how this was is a multiple of the other, they're actually equal. Then, and what does a multiple mean? A multiple means that like one is 2 times the other, 1 times the other, 3 times the other, 4 times the other, a half times the other, and so on, right? That's what I mean by a multiple. All right, I wanted to do one more vector question. Yeah, I wanted to do one like this, where it's not exactly points, but it's like letters. So let me try it and see. All right, try this one. Right. So let's see here. So A WY is WV plus VY. Why am I doing that? Because I actually seeing the line. So notice B going in this direction, right? So if I'm going the opposite direction, this has to be minus B plus A or A minus B. All right? So let me repeat that again. Look where B is. B is here. A going this way. So to get from W to Y, I gotta go this way, and then I gotta go this way. So if you notice here, this would be minus B A. WS equal to a third WY. How did I get a third? Because if this is split into, this is one section here and this is two sections here, then this whole thing is 3. So WS would be a third of WY, which is a third by A minus B. Finally, SX is SW. Actually, let's go to, yeah, SW plus WX. So SW is minus a third by A minus B plus WX. WX, this will be going A because they have to follow the same thing, plus A, which is minus a third A plus a third B plus A, which is 2/3 A plus a third B. R is the midpoint of VW. R is the midpoint of VW. So we're putting this here. This is R. They want us to prove that R, S, and X are collinear. So what did we say collinear? One have to be a multiple of the other. So we found SX, and now we need to find RX. So repeat B. So BWS, they say the ratio is 1 to 2. So if this is one segment here, this is one, and this is two segments here, then this whole thing line would be a third and 2/3. So therefore WS would be a third of WY. And then SX, this will be S to W plus W to X. So when I go S to W, that will be minus WS, obviously, because we're going in the opposite direction. And then W to X would be A. How is that A? Because it's a parallelogram. Just make sure you can see it. Because it's a parallelogram, this A will hold here, and this will also be B. Okay? Right. So the next thing, they're saying R is the midpoint of VW. So prove that R, S, and X are collinear. So I've already found SX. So now I need to find RX. So RX is RW plus WX. We've established RW is a half B plus A. No, you won't lose marks if you leave it as minus B plus A. That's fine. So is one a multiple of the other? Let's see. Yeah, but we did this wrong right now. I think we had to find I think we need to find RS. Yeah, you can. You can use RS and SX. That's fine. But so if you notice here, Rx is equal to, well, this is A plus a half B. Rx is actually 2/3 Sx, therefore collinear. How did I get that? Because this by 2/3, A by 2/3 is 2/3 A, and this by 2/3 is a third B. So notice they are collinear because one is a multiple of the other, right? You could have also done here as Xavier said, you could have also done RS and SX. It didn't matter, right? So once you prove one is a multiple of the other. All right, so tomorrow, linear programming. The reason why I write it here is so that when we start the Zoom, I have it here one time. Linear programming, stats, right? Nah, read it. I'll show you what that is just now. Stats 3, how to approach people. Right, and yeah, maps. Right, so I've got one other formula, right? Cos theta is A dot B over the magnitude of A by the magnitude of B. What I remember, that's only at maths, right? That's the angle between two vectors. Between two vectors. I mean, I could. So tomorrow, yeah, we'll go through some of the past papers and see, right? But yeah, the majority of things here, we're good to go. All right, guys. So that's it for today. I will upload this tonight as soon as possible. Actually, up to like about, yeah, I'm up for a little bit doing applied. So this should go up by tonight self. Okay. I'll post the link in the Google Classroom, but I posted the link here. So y'all could if you don't have the link, just WhatsApp me. It's for the YouTube video. All right, I'll send it to y'all. But yeah. All right, guys. So tomorrow we'll run through these. We'll go through the paper, see what other topics could come. I'll not go too late tomorrow. I'll try to do from 8 again to probably 9:45, so y'all could go and sleep. Tomorrow, as I say, just go do the past papers. Look at some YouTube videos. Use Claude, Gemini, GPT. Get some questions done. All right, but if you do any past papers and you find you're losing marks and you're worried about this question and that question, stop studying about the 20 marks you're losing. Study about the 80 marks you're getting, right? Focus on your strong points. Do not try to learn anything new between now and the exam. If you don't know it now, forget it. Focus on trying to get the things that you do know. All right? All right, guys. So I'll see you all tomorrow. Thanks again for coming out. See you all
Later,
then.
sir.
Later, sir.
Later, sir.
Yes.
Later, sir.
Sweet dreams, sir.
Yeah, it's on, sir.